So we have two more concepts to finish out section 4.3, and the first one is zero exponents. And more often than not, I will hear people say anything to the, well, I never hear anybody talk about math outside GCC, yeah. I mean, generally, we don't talk about math with my friends. But anyways, students, if I ask them about zero exponents, will say anything to the 0 power is 1. And that's a little too generous of a rule. I'm going to write this as a generic rule and try to explain this with my calculator. I'll say any base to a 0 power is equal to 1. Let me show you how zero exponents could come up. Like if I had the problem 2 to the 4th over 2 to the 4th, I can solve it two ways. Or I might be able to even solve it more than two ways. 2 to the 4th is 16. So this problem 2 to the 4th over 2 to the 4th is really 16 over 16. And 16 divided by 16 is 1. I should have even known that without writing it as 16 over 16. But nevertheless, it's equal to 1. If I use the rule for subtracting exponents, I'd get 2 to the 4 minus 4 power, which is 2 to the 0 power. My answers, if I solve a problem using two different methods, although they're allowed to look different, they have to equal each other. So 2 to the 0 must equal 1. And my calculator knows that 2 to the 0 power is equal to 1. I claim the rule is that a base to the 0 power is equal to 1. Sometimes we'd write the rule like a to the 0 power is equal to 1. This is the proper symbolic way to write the rule, but it leads to the mistake that students make. If I gave you a problem like this, and I said, what is 5 times 6 to the 0 power? Well, I'll do it on my calculator, but the rule says base times the 0 power, base to the 0 power is 1. That 0 power doesn't apply to the coefficient. 5 times 6 to the 0 power, the 6 to the 0 power is a base to the 0 power, which is equal to 1. But the exponent doesn't apply to the coefficient. When I'm using the exponent rules, if there's a coefficient and it's not inside of parentheses, the exponent doesn't apply to the coefficient. This is going to be equal to 5. So there's a zero exponent that's not equal to 1, but the base to the 0 power is 1. If I did this on my calculator, 5 times 6 exponent 0 power, my calculator will show me that. And the evil twist of this, if I did something like this, negative 3 to the 0 power without a parentheses, this is the evilest of evil problems. I have to think of this as either the opposite of 3 to the 0 power, or I have to think of it as negative 1 times 3 to the 0 power. In both instances, I'm just finding 3 to the 0 power and making it negative if I want to use the opposite strategy, or multiplying it by negative 1. So the opposite of 3 to the 0 is going to be the opposite of 1, and the opposite of 1 is negative 1. Using this strategy, coefficient times a base to the 0 power, the base to the 0 power is equal to 1, and then I'd multiply. On my calculator, negative 3 exponent 0 power is equal to negative 1. If I do something that seems insignificant and just sneak this into a parentheses, then this fits the rule base to the 0 power. Once the negative's inside the parentheses, it's part of the base. And this means this is a base to the 0 power, and that's actually going to equal to 1. So when we have negatives, if a negative's not in a parentheses, the answer is going to not be 1. But if the negative is in a parentheses, it's going to reduce to 1. I think that's good, but let me look at the sheet that I have written here. Maybe I wrote something brilliant. So the negative exponent rule, or I'm sorry, the zero exponent rule says base to the 0 power is equal to 1. And if you look at this, 5 to the 0 power, 5 is the base, the exponent is 0, that's equal to 1. 9 times x to the 0 power, it's still, the rule applies, but the rule only applies to the base, not to the coefficient. So I separated the 9 and the x to the 0 power to emphasize that the base to the 0 power turns to 1, but the coefficient doesn't. And then the evil non-parentheses negatives with 0 exponents. If I have a negative x to the 0, this means the opposite of x to the 0. The x to the 0 is 1, so this is the opposite of 1. The opposite of 1 is negative 1. Similarly, the opposite of 2 to the 0, or negative without a parentheses in front of a 2 with a 0 exponent. I can rewrite this in words as the opposite of 2 to the 0. 2 to the 0 is 1, so this is the opposite of 1, which is negative 1. And the last two are written base to the 0 power, so they're really equal to 1. So I'm just going to rip through these. Problem 72, that's a base to the 0 power, that's equal to 1. Problem 74, also a base to the 0 power, that's equal to 1. Problem 72, this is the opposite of 2 to the 0 power, which is the opposite of 1, because 2 to the 0 power is 1, and the opposite of 1 is negative 1. We learned opposites, I think in chapter 1. 78, I've got a stray parentheses that I'm going to need to clean out of there. 78 is just an example of a base to the 0 power. If you have a negative number but it's in a parentheses, then that's going to reduce to 1. So negative 2 to the 0 power with a parentheses is equal to 1. Negative 2 to the 0 power without a parentheses is equal to negative 1. So 78 is just a base to the 0 power, and that's 1. I'll do 79 because my 80 is so low. 79, I need to think of this as 2 times d to the 0 power. The coefficient needs to be separated from the exponent here. The d to the 0 power is a base to the 0 power. So this is 2 times 1, and it's going to reduce to 2. This looks crazy complicated, but it's not so much. This is just a base to the 0 power with a really complicated base, but an entire parentheses with a 0 power, it doesn't matter what's in your parentheses. Like if I do negative 4 times 5 times 6 parentheses exponent 0, as long as you have a parentheses with a 0 power, doesn't matter what's inside the parentheses, that whole thing's going to reduce to 1. And that's what problems 81 and 82 are. We have one more concept, and if you've taken any science on our campus, you probably ran into this concept. If I pulled out my calculator and multiplied some giant numbers, my calculator all of a sudden writes an answer that's not that helpful to me. It writes an answer in scientific notation. Scientific notation starts off with a number that only has one digit to the left of the decimal place, followed by a bunch of decimals, maybe it's, a couple, maybe one decimal, maybe a bunch of decimals, times 10 to some power. So scientific notation is a way to write a big number, keeping it manageable. And scientific notation is very specifically has a number between 1 and 9, followed by a decimal and whatever numbers after the decimal, and then some times some power of 10. Like if I wrote how about if I wrote 4.3 0.3265 times 10 to the 6. This is considered written in scientific notation. Scientific notation has one number preceding to a decimal, and it's somewhere between, including 1 and 9. I won't see a number less than 1, and I won't see a number bigger than 9. I'll see one digit to the left of a decimal, and then you could have 1,000,000 decimals. There's no restrictions on the number of decimals. And then after, times some power of 10. And the power of 10 may have a negative exponent. It may have a positive exponent, but the exponent's going to be an integer. So what we're going to need to do is two skills. We're going to need to take something that's written in scientific notation and write it so it's not in scientific notation. And we're going to need to take a number that's written not in scientific notation and write it in scientific notation. So scientific notation is just a way to represent really large numbers so you don't need to write so much. In my calculator, it's programmed to use scientific notation when the numbers get bigger than it can fit on the screen. Let me just jump into the problems. Well, let me just jump into this lovely example I stole from the internet. So if I want to take a number like 52,314 and write it in scientific notation, well, scientific notation has to have a decimal, and before the decimal I need 1, 2, 3, 4, 5, 6, 7, 8, or 9. Well, the first number in the problem, or in the number 52,314, has to be the number that goes to the left of the decimal. So I'm going to introduce the decimal. To get this in scientific notation, I have to have a number between 1 and 9 to the left of a decimal, and then the rest of the numbers, 2, 3, 1, 4, goes to the right of the decimal. The question is, what power of 10 do I get? It's a super easy answer. If the number is bigger than 1, 52,000 is bigger than 1, then the exponent for the 10 is the number of places I needed to move the decimal to get it in the right place. Because there's really an implied decimal after the 4 in this number that's assumed but not written. And I'm going to get rid of that decimal. I'm actually going to move that decimal into the place that it needs to be for scientific notation, between the 5 and the 2. And I needed to move my decimal 4 places. Because 52,000 is a big number, I'm going to move and write a positive exponent. If I do this on my calculator, 5.2314 times 10 exponent 4, and I hit enter on my calculator, it gives me 52,314. The number 3.2, this is already is a good enough number for scientific notation. There's no need to move the decimal. And so if there's no need to move the decimal, I need to multiply it by 1. And 10 to the 0 power is 1. So this says 3.2 times 1. This is scientific notation for 3.2. For problem 3, I need the first number that I write to be 1, 2, 3, 4, 5, 6, 7, 8, and 9. And in problem 3, the first number that I see that isn't a 0 is the 4. I need to get the decimal to the right of the 4. And when I do that, I'm going to move the decimal 1, 2, 3, 4, 5 places. And technically I'm getting 0, 0, 0, 0, 4.28. And zeros in the hundreds, thousands, 10,000s, those can be suppressed. Zeros after the decimal, going after the numbers, also can be suppressed. So I'm going to suppress those zeros, and I'm going to write times the power of 10, and I move the decimal 1, 2, 3, 4, 5 places, so I know I need an exponent of 5. When I move the decimal to the left, I get a positive exponent. When I move the decimal to the right, I get a negative exponent. So that's going to be the scientific notation. Let me show you on my calculator. If I did 4.28, if I did 4.28 times 10 exponent negative 5, it gave me scientific notation. I don't know if I could make it. There's got to be a way to make it not have scientific notation. Wonder if I entered this. If I entered 0.1234428, it puts it in scientific notation. It's programmed to know when it wants scientific notation, and this gets frustrating sometimes for students because the calculator gives them scientific notation and they don't want scientific notation, so we need to be able to get rid of scientific notation as well. This problem 4, I want to get the decimal so that the only number to the left of the decimal is a number between 1 and 9. So I'm going to move the decimal all the way over past the 6, or past the 0, between the 6 and the 0. And now I need to move 1, 2, 3, 4, 5, 6, 7, 8 places. And I can get 6.02, 1, 2, 3, 4, 5, 6 zeros. Just like zeros that lead a number can be ended if they're to the left of a decimal point, numbers after a decimal point that are zeros that tail off can also be removed. And so the number part of this is going to be 6.2, and my exponent, we needed to move it 8 places. If I move the decimal to the left, I get a positive exponent. If I move my decimal to the right, I get a negative exponent. The easier thing to do is take something to get it out of scientific notation. So if I have scientific notation and I want to get rid of it, I move the decimal to the right. If it's a positive exponent, I move my decimal to the left if it's a negative exponent. So this 3.128 times 10 cubed, if I want to get it out of scientific notation, the exponent is positive, so I move my exponent to the right, and then I stop writing the power of 10. That's technically what I get, but I would suppress that exponent. Similarly, 6.4 times 10 to the 4th. Because it's a positive exponent, I need to move the decimal to the right. Because the exponent is 4, I need to move the exponent 4 times. And I need to move the decimal 4 times. Here I need to add zeros because I went past all the numbers. So I'm going to get 64000 decimal, but I don't need to write that decimal. If the exponent is negative, you move the decimal to the left. So 3.9 times 10 to the negative 1, I move the decimal left to the 1. It goes now preceding the 3. And I might write a 0 to the left of the decimal, but it's not necessary. Similarly, this 6.12 times 10 to the negative 5 power, because the exponent is negative, I need to move to the left. And I need to move to the left 5 times. Anytime I move past numbers, I need to fill in zeros. And I need to write the number correctly too, though. And usually, I don't leave a naked decimal like that. I sneak a 0 before it, but I don't always do that. So let's see if we can do this. First 2 problems, write in scientific notation. So in problem 8d4, I need to get the decimal between the 5 and the 6. So I'm going to write problem 84 as 5.678922. Because the number's big, it's not a decimal number, I'm going to get a positive exponent. Or because I'm moving the decimal to the left, I get a positive exponent. And my exponent's going to be, let me see, 1, 2, 3, 4. So that's the scientific notation for that. Let's do 85 together. 85, there's an implied decimal after the third 5. I need to get the decimal right between the 9 and the 8. So I need to go over 1, 2, 3, 4, 5, 6, 7 places. So I'm going to write 9.8996555 times, and I went how many? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7? I went 1, 2, 3, 4, 5, 6, 7. Hold on. I'm screwing up here. 9, 8, 9, 9, 6, 5, 5, 5. Sorry about being a moron. 1 place, 2 places, 3 places, 4 places, 5 places, 6 places, 7 places, times 10 to the 7th. The next few problems, I'm moving the decimal to the right, and that gives me a negative exponent. In problem 88, I need to get the decimal to the right of the 4. So this 0.0000456, I need to go 1, 2, 3, 4, and get 0, 0, 0, 0. That first 0, the next 3 zeros, 4.56. When I move the decimal to the right, I get a negative exponent, and I moved it 1, 2, 3, 4 times. So the exponent should be negative 4, and I could suppress the zeros at the beginning and get 4.56 times 10 to the negative 4. Let's do 89 together, 0.0033. Need to get the decimal there, so I need to move it 1, 2, 3 places. When I move it 3 places, I get 0003.3. I moved it to the right, so I need a negative exponent. I moved it 3 times, so I need a negative 3. And I can suppress those zeros and get 3.3 times 10 to the negative 3rd power. Now I'll go in the other way, taking something that's written in scientific notation and getting it out. Positive exponents, you go to the right. Negative exponents, you go to the left. So in problem 92, I need to take the decimal, since the exponent is positive, and drag it to the right 7 times. So 1, 2, 3, 4, 5, 6, 7. I'm going to drag the decimal there, have to add 2 zeros. So I keep my 800,345. I add 2 zeros. I don't really need to write that decimal since it's not a decimal number. And add my comma. Start at the far right, count left 3, so it's 80,034,500. Let's do 93. So I'm going to take the decimal from my 3.025. It's a positive exponent, so I move it to the right. It's a 4, so I move it 4 times. So I'm going to move the decimal past the 5. I need to add a 0. This is going to be 30,250. Last couple, going backwards. If you have a negative exponent, you need to move it to the left. So in problem 96, says 8.1230 times 10 to the negative 3rd. I'll move the decimal 1, 2, 3 places to the left. I'll add a couple zeros, and I'll get 0.008123. I don't need to write the 0 after the 3, but I probably would sneak a 0 in preceding the 8. For 97, I need to move the decimal 6 places because it's negative to the left. So 1, 2, 3, 4, 5, 6. So I'm going to get decimal and then 1, 2, 3, 4, 5 zeros, and then my 2, 1, 1, 3. Probably put a 0 to the left of that decimal as well. All right, I'm going to stop. Hopefully that was good enough for zero exponents in scientific notation.